the specific situation of rationalising the denominator with surds. So the simplest one was where we have a single surd on the bottom, in this case the square root of 2. And we want to make it a rational number, and obviously square root of 2 is not rational. So how do we do it? Well, we multiply the top and bottom by that surd, because essentially you're multiplying by 1. You're not changing the value of the fraction. But that now rationalises the denominator. We have a rational number. But why do it? And the reason we do it is for the sake of comparison. Right? With fractions, before you can add and subtract fractions, the denominator has to be the same. Same deal. We want them the same because we need to compare so we can add and we know how big things are. If I just leave it as the square root of 2 on the bottom, it really becomes hard to compare that with, say, a third and a half and things like that, because square root of 2, oh hang on, where's that fit in the number line? We don't know what it is exactly. So we like to have a nice exact number on the bottom. Some people are obsessed with rationalising the denominator. Personally, you only rationalise the denominator if you need to. It's okay to leave things with an irrational denominator. If I'm not going to go and compare it with something, that's fine. I mean, a number is a number. But we still need to know how to do it in case we need to do it. 3 on 2 root 5. Well, there's just a single surd there. You only have to multiply by the surd. I don't have to multiply by 2 root 5. I mean, you can. You'll still get the right answer. But it will mean that you'll end up with some cancelling later on down the track. So we have 3 root 5 on 10. But then we have these ones where there's 2 terms in the bottom. We need to make the bottom a rational number. And that's where the difference of 2 squares comes into it. Because every time we do difference of 2 squares, we're going to end up with a rational number. So we multiply by that conjugate. So root 2 plus 1 on root 2 plus 1. That means on the bottom we now have 2 minus 1, which is a rational number. It's a nice one. So on the top we get a perfect square, on the bottom we get the difference of 2 squares. I use this one just to highlight, it's so easy to make a mistake and go 2 minus 3 rather than 4 minus 3. Remember, you're squaring both of the terms there. So we've got 4 minus 3, which is 1, and we get 7 plus 4 root 3, and that will do us for today.